Geotrig, day 4 of lesson 3. We have 2 more problems to finish up here, and this will help us, I do believe, with like questions 19 and 20 in the homework that we'll tack on for tonight's. So we got this particular right triangle, a large right triangle, and it looks like we have a smaller right triangle kind of nestled in on the bottom right corner. Yes? So it wants you to solve for A, B, and C. So if you're looking at this, there are some things you should be able to look right there and say, I know I could solve for this. But then some of the others are not so straightforward. I agree. I think A, because A is part of the smaller right triangle, I have a leg and a leg, and A ends up being the hypotenuse. Remember, variables are just anywhere. When we use a formula, we're just using specific variables to kind of highlight different places. So yes, how do we solve for A? Right, I want to use A squared plus B squared equals C squared. Don't get it mixed up with the A, B, and C of this particular problem, because that's not true. Okay? What do I use for A and B in this problem? 4 and 6. And that will equal the side or length A, the hypotenuse of the small triangle, squared. 4 squared plus 36 equals A squared. What's 16 plus 36? 52. So is everybody okay with getting 52 so far? I squared the legs, added them together. To get A by itself, I take the... So what I do to one side, I have to do to the other. Now wait a minute. Normal circumstances, if I'm solving for a variable in an equation, and I take the square root, I should probably have what? I didn't. Someone said something. I don't know if I heard it.
Square root?
We're doing that. We're square rooting. But I took the square root of both sides.
Okay. Oh, plus minus.
Plus or minus.
Oh, that's
Normally, there are 2 answers that when I square it, as in I place it in A and I square it, 2 positives make a positive. 2 negatives make a
negative.
Positive. And so therefore, I will get a 52. So when I square root, we always like to put a plus or minus. But in this case, I'm only going to take the positive and say that A is equal to the square root of 52. Why?
Because there's no square root.
Well, square root of 52 is not a nice number, so it's an irrational number. Emily? You can't have a negative length. And so distance on a side length is positive, so therefore we're going to stay with the positive number. Now, guys, we could leave it as square root of 52. You could go on your calculator and put square root of 52 on there, and you guys would come up with what? 7.221. Okay, that's an approximation. That is not the true answer, right? That's just an approximation of what the square root of 52 is. It's really close. What if I said there was another version of square root of 52, and you guys have done this already? Simplify it, which means go to the square root dance. Jan? Square root? Square root is the symbol here.
Yeah, 2 square root
13?
Yeah.
How did you get that? Is everybody okay with that?
Calculator.
Calculator? Some calculators actually can reduce this for us. Now, Jan wasn't here in the beginning when we actually simplified square roots. We did this in class, did we not? Okay, so my understanding is we didn't cover it this year, so I'll go do a little bit of rundown here. I say if I'm going to a square root, I'm going to go to the square root dance. Okay? Which means if I'm going to go to the dance, I need to have a partner or a date. That's the rule. Why is that the rule? Because what's really tucked inside right here? What's there but it's not? It's a 2. It's implied to be a 2. Guys, if I was going to the cubed root dance, I would need groups of 3. Fourth root, 4. So that number inside is like the bouncer or the gatekeeper letting you out of the house. Okay. Now, this is my process. I take the number inside and I break it down to its prime factorization. 52, we can say, is 2 and
13. 14.
No.
13.
2 times what is 25?
No, it's not. Nothing.
26, thank you. 2 times 26 is 52, guys. Now, I see that 26 is also divisible by 2. 2 and what? 13. I've now broke it down to the lowest or the smallest factors, or the prime factorizations, because 2, 2, and 13 cannot be broken down anymore. Correct? So now, this is what I do. To make it oversimplified for now, later you guys won't have to do this, I am just going to quickly write down all the factors in order, all grouped up. So they're all grouped, 2, 2, and 13. 2 times 2 times 13 is, it should be 52. So we didn't change anything. I'm just using simple substitution. Yes?
Yes.
Now, the rule is, to go to this dance, I need to have a partner. And so I go back and I circle all of my pairs. If this was a cubed root, I'd be looking for groups of 3. If it's a fifth root, groups of 5, and so on. Okay? Now, those 2 2s actually get to go to the dance. So they're going to leave. When they leave, they join hands and they become a factor of 2. They just become 2. So when they join hands, really what's happening, guys, is this. I'm letting them leave in almost like their own little car. You guys remember the rule that if I have a square root of 2 things being multiplied, I can separate them to their own square roots? It's one of those rules you guys would have learned last year. But what is 2 times 2?
4.
And what's the square root of 4?
2.
It's 2. So when they leave, they become a 2. Now, 13 doesn't have a date. 13 has to stay home, and the home is the square root. Guys, I'm just trying to put some kind of scenario that you guys can remember, hopefully, how to take or simplify a square root. So, that means that if you took 2 times the square root of 13, you will have the same thing as the square root of 52, which is 7.21. Please take out your calculator and verify that for me. So we still need to go find the others. To save myself some room, I'm going to get rid of the work that we did. And so now we can start working on B and C. So, So to start to do that, I will definitely put on here that this is 2 square root 13. That's the value of A. Okay? So I don't have to use A anymore. I know what it is. Remember, this book is not going to want approximations. It wants the accurate, true value. So, what can I do? What do you see again? What shapes?
Square. Oh my God.
I see how many, what? 2 triangles. Can you guys make those 2 triangles? The small one is 6, 4, and 2 times the square root of 13. Yes? Okay. The larger one is C. What's the bottom length? 10, because it's all the way across from the corner here all the way, so 4 plus 6. And the hypotenuse happens to be B plus 2 times the square root of 13, or B plus A, which A was 2 times the square root of 13. There's one other piece of information that we're not using yet, and it's not always given to us. In this problem, it is. What do we see? The 90-degree angle. We have those listed. They're both right triangles. That helped us do or use the Pythagorean theorem. It's this thing right here. They don't always tell us this or show us. You just have to know it. That means that this angle is that one, right? But isn't that the same angle as the one over here?
No.
Why not? Didn't it come right out of there? Didn't I take this triangle from that position right there? I just took it, pulled it out.
On top of it.
Yeah, so these actually overlay each other.
Yeah.
Those are the same angle.
Yeah.
It's beyond 13.
Oh, that's helpful.
Sorry, yes.
Oh, shoot.
Guys, we fixed this to make sure it looks like a B and not a 13. Now, so we found the angles. And like we talked about yesterday, if two angles are the same, that implies all three are the same. So I'm going to go back and I will place 2 tick marks on these, because now if all the angles are the same, they are, starts with an S, similar. And if they're similar triangles, guys, that means they have to have a common scale factor. There's a scale factor between them that's the same for all the sides. Which angle has the scale factor associated with it? Which one?
Right to the left.
If you can go right to the left, that's fine. But
Okay, so. No, well, if we're gonna make it like that.
they're all denoted by tick marks or a box. So which one opens up to the scale factor? Does the 90 degree have numbers opposite them? Only one. That's not it. The single tick mark? Hey, there's a 4. We're good. But then over here has a C. That's not good. So it must be the double. 10 and 6. Now I heard someone else say, hey, let's do the right to the left today. So 6 is to 10 as 2 square root 13 is to B plus 2 square root 13. Cross multiply to solve. We also can say that 6 to 10 is equal to
C, or 4 was to C.
4 is to C. Which one's easier to solve for? I think the second one. But the 6 over 10 equals 4 over C.
Maybe.
Yes.
10 times 4 equals 6C. Divide by. So C is equal to 20 over 3. So we found C. We found A. I gotta circle A. So that's A. Okay. This thing, though, is gonna be a little crazy. Let me move it to another page. So let's cross the corners here. Oh, that's why it's going on. Okay. Let's cross these two first. 10 times 2 times square root 13. is what? 20 square root 13. Guys, don't make this harder than it needs to be. Don't multiply the 10 inside with the square root of 13 because you can't unless you change it. Equals, I'm not even going to mess with it right now. I am going to leave it in the form where I have to work with it here. I have to get b by itself. I could distribute the 6 in. Or, what? Yeah, divide by 6. That's the first move I would make. Make my life easier. Because now you have b plus 2 square root 13 equals, I can reduce it. Top and bottom, divisible by? 2 more, yep, 2. Yep, sorry. Which would be 10
Over 3.
square root 13 over 3. And now all you have to do is get b by itself by, yep, subtracting 2 square root 13 from both sides. These are cancel. B will equal, now here's the problem. These things don't have common denominators. That's easily accomplished by multiplying this one, which is really over 1, yeah? By what? 3 over 3, right?
Oh, yeah.
You do it to the top, you have to do it to the bottom, and vice versa.
-6.
So, let's just kind of rewrite so that we don't lose anything. Minus 6 square root of 13 over 3. Is everybody seeing this process? Everyone in here can do this process. Did it take a little bit of thinking to get here? Yes. It wasn't past anyone though. And then if you have 10 of something and you minus 6 of something, how much something do you have? You have 4. You have 4. And what happens to be the something in this problem? Square root of 13 over 3. You now have B. This one, find A, B, and H. This one, pretty classic problem throughout the book that you'll see over and over and over. This one is interesting because it doesn't just set up 2 similar triangles, it sets up 3 similar triangles. We're going to walk through this one, so pay attention very carefully. Using the same idea, we'll have Pythagorean's theorem in there, we'll have a couple different things. But I hope everybody can see we have a larger right triangle. Yes? Where we would have A, 12, B. We also have the left right triangle, which is 4, H, and A. And we have the one on the right, which happens to be 8, H, and B. Those 3 triangles are actually similar to each other. How do I know this? Because of the tick marks that are going to be placed on here now. Using the same fact that triangles, as this inside triangle is pulled from the left side of the larger one, means that this angle, which is a single tick mark, is the same as that angle. Yes? Going all the way across using the same thinking, that has to be a double angle because this one's a double angle. Right?
Yep.
And wait a minute. As you can see, the larger triangle has all 3 tick marks. It has a 1, 2, and a 90 degree. This one here has a single tick mark, which matches here. We have a right triangle angle, so that matches there. That means that this double angle, and the angle between A and H also is the same as a double angle. All three angles the same, they are similar. Same thought process. This is a right triangle with a double angle. The third one has to be single. Using the same logic as we just did. That means that we'll name them as, I'll change colors, triangle 1, triangle 2, and triangle 3. Triangle 1 and triangle 2 are similar to each other. They'll have a scale factor. Triangles 2 and 3 are similar to each other. They'll have a different scale factor. And 1 and 3 are similar. They'll also have a scale factor to each other. Notice, did I not say that 1, 2, and 3 all have a common scale factor? Just when you compare two of them at any given time. So your goal then, guys, is to find which triangles can give us a solid pair of numbers. And when you do this, you're going to find something kind of interesting happen. So let's just, for fun, take 1 to 2. 1 over 2. Say we can't find the numbers, let's just list them all. So if I go for 1, we'll start with A. A is opposite the double. And so I go to 2. There's the double. Opposite is 4. That will equal, let's give another one. Another side of number 1. B, awesome.
B.
So B, which is opposite the single band, sorry,
Would be A.
and the single band is
Would be A.
H. Is everybody following? I'm just finding opposite corresponding sides to their angles. That would be 12, which is the remaining one. 12 is opposite the 90, which is
A.
A. Oh man, Mr. Konchak, didn't you just say we're supposed to find the one that gives us a pair of numbers?
But wouldn't it be squared? If you did the A.
Because that doesn't give me anything, right? Here's the thing. I think what Jake's trying to get at here, without letting him speak, is I have to set two of these fractions together. First two, last two, or the first and last one. And it seems like if I set the first two together, I am left with 3 variables. Not good. I need 1 variable with 1 equation. The last two still have 3 variables. Not good. What happens when I set the first and the last one equal?
A squared.
Yes, it only has a's in it. So therefore it's 1 variable. I can solve it. So if a divided by 4 is equal to 12 over a, when I go to cross multiply, I'll have a squared equals
48.
48. Can you solve for a?
Yes.
Square root, square root. So we're going to say that a is the square root of 48. Yes, it can be reduced. I expect you to reduce that. For now, to save time, we won't. Okay? Did everybody see how I came up with the idea of stating all 3 of them? Finding which 2 of them gave me just a single variable. Do the exact same thing with another 2 sets of triangles. Someone name another 2 sets of triangles.
3.
It's not that hard, guys. 3 to 1. Okay, let's do that. We're going to put 3 on top, so let's start with H. H is opposite the double, going back to 1, which would be A. That's probably not going to be a good candidate for us, is it?
No.
Okay, but equals, next one, let's do 8. 8, which is opposite the single,
B.
which would be B. That could be an option. And that will equal the last term, a B over
12.
12.
Oh. Oh, wait, no, that's good.
That's good right there, isn't it? Can we solve for B?
Yeah.
All right, so now we know A, we know B. We probably could do the exact same thing to solve for C, but what's 12 times 8? 96?
Yes.
So square root, b equals the square root of 96. Again, reduce this, guys. Do I still need to keep doing this, or can I revert back to something else to solve for a? Oh, no, I already have a. H.
H.
Can I revert to something else to solve for h? Where is h?
2 and 3.
H is in this one. Right here, or is here, which is in this triangle. Wait a minute. If I know A, I know the hypotenuse, I know a leg, that means I can find the other leg using Pythagorean's theorem. Right. So I can use A squared plus B squared equals C squared. Remember that C squared, or C, is the hypotenuse. We're changing up variables in our problem, though. So, let's look at triangle 2 here and use that. So we said A, which was
Square root.
the square root of 48. But that, in our equation, actually is letter, oh my goodness, it's C. But that should be okay, right? Is it 48?
Yeah, it's 48.
Okay, so square root of 48 squared. Hey, that'll turn out to be a nice number, won't it?
48.
Yeah, that'll turn out to be 48. That's going to equal the other two sides. Doesn't matter the order. So one of them is,
Square root of 96.
no it's not, it's
No.
4,
It's 4.
because we're talking about the other legs here, 4. And then the other one is h squared. So 16 plus h squared is equal to 48. And if I subtract 16, I know it's squishing it on the bottom there, h squared is equal to 32. Square root, h is equal to the square root of 32. Again, you need to reduce or simplify it. But you now have A, B, and H. And we did this by creating 3 triangles, setting up the ratios, and you were good to go. Homework on lesson 3, day 4. I just want you to do 9 and 10, which are like the examples we just did. Try to do them without the examples. Have a great day.